Good morning, everyone. Welcome to geometry class. Today, we want to focus on the definition of parallel lines. First, let's review three undefined terms. So I talk about the detail for these three undefined terms: point, line, and the plane. Plane I didn't talk very detailed last time. But today I will talk more about the plane. So first, our real life is 3D, 3-dimension. So we say plane is only 2-dimension, and a line is 1-dimension, and the point 0-dimension. Why our real life is 3D, 3-dimension? Because this is our real life. We may call it space. We have length, width, and the height. So if you have only a length, then it's 1-dimension. If you have length and the width, length and the width, so you have 2-dimension, because 1-dimension, 2-dimension. Okay, you have 2-dimension. And the 1 point, we don't say there's any dimension, just 0-dimension. 1 point is 0-dimension. And mathematically, when we talk about a point, is no size, no length. So we cannot see the point on our real life. We cannot visualize it. But in the class time, I need to show you where it is, because the point also tell you where the point's location is. So in order to show you the location of a point, I need to draw a little bigger so you can see it. So I use a dot to show you where is the point. But remember, the point itself is really little tiny, only exists inside your imagination. Therefore, a line consists of all the points together become a straight line. They have no thickness, because the point has no size. Therefore, the line has no thickness. But this line can extend to both directions. Now, when we talk about plane, length and the width. Now, when you have length and the width, we say these two lines is on the same plane. Why? Because if you have only one line, like if you flip your book, you have so many pages of your book. Each page is a plane, and many planes go through the same line. So go through one line, there are so many pages flip over and over around this line. How can you decide which plane you are talking about? See, if you are talking about this plane, then you need one more line to decide. So you are talking about this line and this line to form a plane. So a plane has 2 dimensions. we talk about length and the width. And they can extend infinitely in all directions. Here, even though we say all directions, but actually it's harder to extend on all directions. So it's easier to say a plane. You can extend here, extend there, and you can draw one more line, go through the same, these two lines. If one line goes through these two lines, we guarantee there will be on the same plane. Why? We will talk about more later. We don't talk about too much or the detailed concept. But when we say all directions, means all directions on the same plane, not the all direction on, like if you have one plane here, and you can extend this plane on all the direction, that's okay, because they are all in the same plane. But you don't extend to up and down directions, because they are not in the same dimension. So this plane is a new thing you can keep in mind and think more. But today I will only talk about a little bit for the plane. And because this plane consists of so many lines together, or so many points here, and the point is no size, no length. Therefore, this surface or this sheet, like a paper, has no thickness. So this is the review for the undefined terms. Now keep going. Before we learn the definition of parallel lines, or we learn how to construct a parallel lines, you need to learn more definitions. So first one, ray. I think I will just go over those vocabulary words because I think you learn those things from your algebra. Those. So rays, we draw a ray from one start point, one end point, and keep going forever to the other end. Angle, two rays with the same vertex. So vertex means the point where two or more lines or rays or line segment meet. Here, that's what we call vertex. Congruent means equal, but sometimes mathematically congruent we would like to use this symbol, not exactly equal, because sometimes they just have same size and the same shape, but on the different location. Like if you have one angle here, the other angle here, they looks similar, looks the same size of the angle, but on the different location. So same shape, same size, we say congruent. Not exactly equal because they are different location. Right angle, 90-degree angle. Straight angle, 180-degree. And cut in half, 90-degree. We call it right angle because if you have a triangle ruler, there's one angle is 90-degree. It's perpendicular to the line, to the baseline. Line segment, you have two ends, A, B, two ends. No extension, none. If you extend, then become ray. If you extend both sides, become 9. So 9 segment, no extension. So you have 2 endpoints. Let me use other color. Oh, I didn't change the color. 2 endpoints. That's called 9 segment. Straight angle means if you have 2 angles put together or small angle put together, 1 angle, 2 angle, 3 angle, or 2 angle, doesn't matter, 1, 2, 3, put together form a straight line. So 1 ray and 1 angle, and start from here, another ray, and the last one, the last ray, and the first ray together become 1 straight line. Then it's 180 degree. Why is 180 degree? Because we decide a whole circle, we make it 360 degree. So you start from here and make this angle bigger and bigger and bigger, keep going up bigger and go back to original place. You go around one circle, we say this is 360 degree. So cut in half a semicircle, then divide by 2, 180 degree. And divide by 2 again is right angle, 90 degree. Transitive property of equality. If, let me change the color. If x equal to y and y equal to z, so it kind of like x equal to y and y equal to z, like a chain. So we all also call this property, we also call it as a chain rule. Then x equals to z. So y will work as a bridge. So go through the bridge y, x equals to z. So this, we are going to use this property. This is not definition, this is a property for our proof today. And talking about the proof, because this is only the second video, you're probably not very familiar with all the geometry terms. You still need more time to learn, even though I expected you learn those defined terms from your algebra class. But anyway, for today's proofs, it's not too hard. That's why I put it here. But if you feel it's too hard, you say, oh, it's hard for me to learn how to do the proof. Today's class not purposely for you to learn how to do the proof yet. Today, we only focus on what's the definition of parallel lines. So as long as you understand the parallel lines first, and then you understand the proof, you agree with the proof, then that's good enough. You don't need to really learn how to write down the proof yet. So let's keep going. Triangle, everyone knows what's triangle, right? And the triangle, be careful, triangle, even though you have 1, 2, 3, right? But they are only 2 dimensions. Remember, 2, 2, okay. 2 lines, you already decide this plan. We will talk about this pretty soon, okay? Why triangle is 2 dimensions only. And the same thing as when we say a plane is 2 dimensions. So a plane figure with 3 straight sides and 3 angles, we call this a triangle. These 3 angles has 3 vertices. So that's a definition of triangle. So before we keep going to the definition of the parallel lines, we want to learn how to construct these three undefined terms. It's very easy to construct. First, you want to construct a point. Remember, when you construct a point, you need to draw it like a dot. And we pretend it's a little tiny point. You cannot visualize the point. Now, we use portrait to construct line and the plane. When we talk about the definition of lines, we said lines are undefined terms. So we kind of feel it's obvious, right? If these 2 points, if you have only 1 point, let me erase this one. Okay. If you have only 1 point, I say I make it as a dot. 1 point, go through 1 point. You can draw many lines here. But all the lines need to intersect at the same dot or same point. Because my dot is way too big, therefore you lose like how can I draw a line here? Can I draw a line there? No. If you draw so many lines, create too many different vertex, then this is not one dot, not 1 point. Vertex for 1 point need to only have 1 dot, right? So because the points only exist inside your imagination, so this is kind of hard to draw. Okay, but you need to use your imagination to think about. The point is very little tiny. So even though you can draw so many lines from different direction, but they were supposed to intersect at only 1 point, at this point. But if you had 2 points, how many lines you can connect? So the portrait telling you 2 points decide exactly 1 line. 2 points decide exactly 1 line. So you may say, teacher, I can draw more than 1 line, so I win. I'm better than you. You can only draw 1 line. I can draw many lines here, but then you are wrong. Okay? That's not possible for you to draw more than 1 line, go through 2 points. Because remember, our point is very little tiny, no size. And you can draw too many so many lines go through these 2 points because you draw dots. You draw dots. Dots is big enough for you to draw so many lines go through. But we are not talking about dots. We are talking about the points. Go through 2 points. Still, you need to use your imagination because there's a portrait. No way we can prove it. So it's kind of obvious because the points are so little tiny, you are only allowed to have 1 line go through these 2 points. So how you construct a line, you just, if I give you 2 points, you just use your ruler, connect them. In the real life, I won't be so picky for how you connect these 2 lines, as long as you only graph connect only exactly 1 line. Don't give me 2 lines, okay? Only 1 line. Then you are done with your construction. You construct, okay? You construct a line. And how you construct a plane. So let me talk about usually our table has 4 legs. 1, 2, 3, 4 legs. And it's very commonly happen. The table will be shaky. Why? Because we only need the 3 legs to keep a balance. And if you have more than 3 legs, you need to guarantee the 4th leg is on the same plane with the other 3 legs. Okay, so we have a if we have 3 points, we connect these two. It's 1 dimension. Connect these two. So my line is ugly. You have 2 dimensions. Now, if you connect 1 more line, but this line goes through the same these 2 lines, then you are not in the 3rd dimension. You're still in the same dimension. Okay, so 3 points decide exactly 1 plane. This is postulate. Postulate again is no way to prove it, and it's easy to understand. Okay, but I want to tell the students who decide this is postulate or not. It's our genius mathematician. They decide which one is the postulate, which one is the theorem. Theorem means you need to prove it. But the postulate, you don't need to prove it. But you don't decide by yourself. So in the test, I ask you to prove a theorem. And you say, teacher, this is too obvious. I don't need to prove it. So I say this is postulate. Sorry, okay? If our mathematician decide that this is theorem, means there's a way to prove it. And you have to prove it to earn credit. So postulate is something obvious without proof. So you don't have to prove it, but you don't decide which one is postulate, which one is theorem. Okay, but right now 3 points decide exactly 1 plane. This is a postulate. Now, so the plane, how to construct a plane? If I give you 3 points, or you can just draw 3 points, but these 3 points don't supposed to be on the same line. If on the same line, you can have only 1 line, right? So if you have 2 points, you connect a straight line, and then you choose another point outside, not on the line. Okay, not on the line, and then you just connect with the previous 2 points. Then you construct a plane already. So that's the way you construct a plane. Now keep going. So before we really goes to talk about the parallel lines, there's one more thing we want to prove for you. We call vertical angles theorem. If you have 2 lines intersect at 1 point, we call this point a vertex. And after you construct these 2 lines, you have an intersect with a vertex. You are going to find 1, 2, 3, 4. 4 angles. So when two lines intersect, the vertical angles, what's the vertical angles means? On the first page of this video, I talk about vertical angles, 1 and 2. Two angles opposite to each other, we call it vertical angles. So that's a definition. Or you can say the other two angles, 3 and 4. These two angles opposite to each other, also they should be equal, congruent. Measure is equal. Measure angle 1 equal to measure angle 2. Or you say angle 1 congruent to angle 2. Okay, so right now I would like to prove angle 1 congruent to angle 2. And by using this angle 3 as a bridge. Now, this is a straight line. A straight line need to be 180 degrees. And also, this is another straight line. And this straight line also 180 degrees. So you can see that angle 1 plus angle 3, 180. Angle 2 plus angle 3, also 180. So that's how we do the proof. So I formally wrote down the proof here. Let me make this smaller so you can see the picture with the written proof, my statement. Okay. Oh. Okay. Okay. So 9.1 and 9.2, when you write down a proof, you have to write down given. Given from the picture or from the statement, you can figure out. You have two lines intersect at point A. So you draw a picture, and according to the picture, you can write down easily. You don't need to write down all the statement. You can use a symbol. You can use math. After you draw a picture, then you can use a math symbol to write down your statement instead of the very long sentence in English. So 9.1 and 9.2, you draw two lines and you mark the intersect point A as a vertex. Okay, so let me erase all the marks, too many marks here. So I will assume you understand, right? Okay, so it looks better now. So this is point A. And I use angle 3 as a bridge. So angle 2 plus angle 3, a straight angle, is 180. Angle 1 plus angle 3, angle 1 plus angle 3, a straight angle, also 180 degree. So reason. Left hand side is a statement, and you write down reason. Number 1 statement, you need to provide the reason. The reason is this given. Number 2, y is equal to 180. You provide the reason, straight angles That's a definition of the straight angle. You have angles plus together equals to 180 degree. And again, you are not required to learn how to write the proof yet, but by take a look at how I prove it, then I'm reviewing your definition for you. Now, since they all equals to 180 degree, remember x equal to y equal to z, then y as a bridge, you have x equal to z. So angle 2 plus angle 3 equals to 180 degree. So 180 degree is the bridge. And then 180 degree also equals to angle 1 plus angle 3. So you ignore 180 degree because 180 degree just a bridge. Now you have angle 2 plus angle 3 equals to angle 1 plus angle 3. Now you can see both sides has angle 3. You take away angle 3. So what's left? Angle 1 equals to angle 2. So angle 1 equals to angle 2, which we say the vertical angles are equal. So finally we say conclusion. So this is the first example, and I detailedly go through the proof, and you can just take a look. I think once you go through proof, it's better than you simply only memorize the formula. If you want to memorize vertical angles are equals and you didn't go through the proof, it's easy to forget or it's harder to memorize, or even you don't remember or you don't understand, right? So once you understand, then it's better. Okay. Now here, before we talk about parallel lines, kind of everyone will say, I understand what parallel lines means. So without talking about the definition, parallel line looks like these two ends. If you keep going, they won't intersect. This won't happen. So parallel line means never, these two lines never touch each other. But what's the real definition? We want to talk about more detail today. And before that, I want to show you this one. If you have two planes, plane 1 and the plane 2. If these two planes parallel, means plane 1 these two never touch each other, no matter how you extend. These two planes no intersect. So if you have one line on the first plane and the other line on the second plane, because they are on the different plane and these two planes never touch each other, obviously these two lines will never intersect. But no intersect doesn't mean parallel. That's a problem. Okay? Parallel line never intersect, but no intersect doesn't mean they are parallel. So if two lines does not intersect and on the same plane. So if this line actually is here, okay, but I can see they never touch each other, then this line in the same plane and they never touch each other, then I will agree it's parallel, okay? But the situation here on the graph here, these two lines obvious not like we say usually we talk about parallel line looks like a railroad track. Should looks like that. Then we say it's parallel line. And why these two never touch each other, but not a parallel line. Doesn't look like a parallel line, obvious. And why is that? Because they are not on the same plane. In this situation, we call these two lines askew. But today we don't focus on this type of the lines. Okay, so I just use this photo to show you. When we talk about two parallel lines, these two parallel lines need to be on the same plane. So then we can keep going to here. Next. Okay. So two parallel lines need to be on the same plane. And what's the definition? Stay the same distance apart. If they stay the same distance apart, then they won't intersect in the end, because they still need to keep the same distance apart. If they are always apart, how can they intersect? And never cross each other. So the formal definition will come soon, but this just, you have 1, 2, 3, 4. These 4 pictures will show you if you have two lines, what happened to these two lines. Very special case is these two lines perpendicular to each other. Perpendicular means these two lines form a 90 degree. And if these two lines does not form 90 degree, doesn't matter 90 degree or not, okay? 90 or not 90, doesn't matter. When they intersect at one point, then it's not parallel, just regular two lines, okay? And if these two lines never touch each other, then we call parallel lines. But if two lines never touch each other but on the different plane, then we still don't say it's a parallel line. We say it's skew lines. So there's some extra information for you. I think this is not hard to understand. So we will keep going to the real definition of parallel lines. Now you have to pay attention. A parallel line can be defined as two lines in the same plane. So I make the color bold. And very important, we never mentioned about that. We say this is like a railroad track. What's the railroad track? Because they have equal distance in between these two lines forever. If you extend forever. So equal distance is very important. Usually a definition can be treated as a given. If I give you two parallel lines, I give you the distance are all equal. And never meet. So you need to remember 1, 2, 3, never meet. You already agree right? And the new thing is they need to be on the same plane and the equal distance. Now there's one extra thing I will mention right now, but I will focus the type of the logic on the future video. But right now I want to tell you definition have two ways. You say if you have pair of lines, then you have 1, 2, 3. But when you talk about definition, it also means if you have 1, 2, 3, means these two line parallel. In other words, if two line parallel, then these two lines will be on the same plane and the equal distance and never meet. You have this the logic we are going to learn in the future. But let me tell you right now a definition like that's me, this my name, something like we are identical. Okay, then, but it's more than that because you say other people have same name. Okay, so this is not very perfect examples. But for definition, yes, pair of line, then guaranteed they are in the same plane, equal distance, and never meet. If two line, same plane, in the same plane, has equal distance and never meet, then guarantee these two lines are parallel. So there's a definition. And what distance means? This is also a new thing. And why geometry is hard? Because the students did not pay attention from the very beginning, like this our second video. So kind of like in the beginning of class. First video, I only talk about undefined terms. And today I started talking about definitions. So it's just in the beginning of the geometry class, and most students, they don't pay attention on these detailed things. They say, oh, everyone knows what's parallelize. If you don't pay attention on new things in the beginning, and you only want to wait for teacher to show you formula, and you try memorize formula and try to calculate, that's not a math, not the geometry and not the math. Okay, so you have to understand every detail. Also, the definition need to be well defined. Why need to be well defined? You don't want to define something against the real world. If your definition against the real world, then you need to live in your own world alone. Okay, so now what distance means? This one is hard. Everyone knows distance. But when we talk about distance, what it means. So okay, I need more space. So if you have 1 point and 1 line, this point is not on the line. If point is on the line, then the distance is 0, obvious. So if outside the line there's 1 point, how you find the distance? You need to use perpendicular line to find the distance. Why? Is this distance? Is this distance? Is this distance? Is this distance? Right? If you have 1 point outside a line, and how you find the distance? So many different type of distance. We want to find the shortest line segment. We call it distance. So among so many possible distance, which one is the shortest distance? And how you find the shortest distance? Perpendicular line. You draw a perpendicular line. Perpendicular line means 90 degrees. How do you know? How you draw a 90 degree? You can find a straight ruler. Straight ruler. And then they will provide a 90 degree. You this one here. And then you say, okay, this is the 9 segment which perpendicular to the given line. Okay. And then you measure from the given point and to the end of your straight ruler. This is the distance from one point to a line. Why? Because you can see that when you have a perpendicular 90 degree, you have a perpendicular 9 segment, you form a 90 degree. And a 90 degree triangle hypotenuse always bigger than a leg. When you measure distance, you won't measure the distance on the line, right? So you are going to measure either this distance or this distance or this distance. So other than the leg, the other lines, you consider they are distance wrong because they are hypotenuse. This is not distance because it's hypotenuse of the triangle. Then hypotenuse is always bigger than the leg. And in the geometry, we are going to learn more concept and prove more theorem to show you hypotenuse is greater than the leg. But today here, we simply just use it. Okay? We don't want to focus on other than the parallel lines. If you, in one video, you learn too many things, it's too hard for you. Okay? But understand when you are talking about shortest line won't be hypotenuse, need to be leg. And the leg will be perpendicular 90 degree to the given line. So perpendicular line intersect the given line to form a 90 degree. Therefore, this page basically is very, very important when you are learning the definition of parallel lines. Equal distance. And you use perpendicular 9 segment to find the equal distance D. And this equal distance D will be the leg of a triangle. When I write down something in these big words, means I would like you to remember this page. This page is so important. Okay. Now, this a little headache here. I always say a postulate. A postulate is something you don't prove it. But don't feel so happy, okay? Why we don't prove it? Because we feel the postulate is so obvious. So obvious, so you don't need to prove it. And students probably really like a postulate because we don't need to prove it. And it's so easy and obvious, but not this one. Okay? The Euclidean number 5 parallel postulate is not that obvious. And if not obvious, many people many mathematicians, they try to prove it fair. It's not easy. Okay, not easy to prove. No way to prove it. Not a success. To prove. If you prove it, then it becomes theorem. But because cannot prove it, and you don't want to say it's obvious, so what happened? This mathematician is a genius. He decided you need to have a postulate to start talking about parallel lines. Otherwise, everyone's stuck there. Okay, so I will say sorry. If you feel this postulate is not so obvious, and you just pay attention, I'm doing my best to convince you and help you to accept. Okay, so let me talk about what's this postulate talking about. This postulate, first you have a statement, and this statement I make the word smaller because it's harder to understand. But I still will talk about number one today. But I will talk about number two first because number two is easier to understand. Number two kind of came from number one, kind of too, this one is obvious, kind of too obvious. So it can be a postulate itself. If you feel this is obvious, good for you. If not, don't worry. A lot of people don't feel it's obvious. But anyway, if you have a line, and outside the line you have a point, and this postulate number two is telling you, go through this point, there is exactly one line can parallel to the given line. Only one. If you can find one, then you don't need to find second one. It's done. Okay. And remember earlier when we talk about the definition of the parallel lines, you draw a perpendicular line, and then you had 90 degrees, you had the distance, and everywhere are the same, right? Same distance. So that's kind of idea. If you have same distance everywhere, looks like you can guarantee only one goes through. Do you? Do you feel it's obvious or not? Anyway, our genius mathematician think it's obvious, and I think so. It's obvious. If you don't feel comfortable, then you probably wait till I talk about number one postulate. Okay. Go through a given line, and the outside this point, a point outside this given line. If you want to keep the same distance, there should be only exactly one line can be parallel to this line in the same plane. And because according to our definition, the distance are all the same. And if the distance are all the same, next video I'm going to talk about congruent triangles. Once you learn congruent triangles, then I can prove these two triangles should be equal, therefore these two should be equal. So if outside the line you draw a perpendicular line, and if you have different angle, you can find the number one if it makes sense. Or later we talk about number one and go back to talk about if you use number one, and then can we guarantee distance equal? So there's another logic issue. And also you need to learn more. to understand. So here again, in just the second video, I don't want to confuse my students with a lot of information. So if you curious or you already feel, wow, I have too many questions want to ask, then you are good. Because when I talk about up to here, you suppose feel you have a lot of questions want to ask. If you don't have question to ask, not too good. But if you have many questions to ask, I don't want to answer you right now. Okay, so anyway, be patient. Just keep in mind, if you feel hard, that's normal. Means you are good. Okay. Now, so number two, I think it's kind of obvious, right? Go through outside the point. You are only able to draw exactly one line to be parallel, and this is portrait. Don't ask me to prove, and you try your best to agree, and if not, think about it. And when we talk about number two, number one, then you feel probably you feel better. So number two right now. So in this video, I will use number two of the portrait file. So I use this portrait to construct a parallel lines. And I will talk about number one later. Okay. Now use number two to construct a parallel line to a given line is easier than use number one. Because number two is telling you exactly one. As long as you can find one, then that's good. Okay. Now keep in mind, let me go back to the definition of parallel lines. Remember, on this page, when I first talk about the definition of parallel lines, I focus on distance and the perpendicular. So I talk about the 90-degree and the distance, all the same everywhere. So when we draw parallel lines, you need to make sure you follow the definition. Okay, so let me construct the parallel lines for you, and let me make it a little smaller so we can have the whole page together. Here, how to construct a parallel line through a point P to a given line L. Sorry, let me erase the M, because right now I copied this graph from online, and they use M as the name of the line, and here on my typing I use L, so I change the name of the line. So this 9L, 9L. Okay. Now remember, from the P you want to find a distance. How you find a distance? Same thing, you use straight ruler. Straight ruler, you put it here. That's the ruler, right? Then you construct a 90-degree and extend. You use a pencil with a ruler, and you draw this one. So that's P. And then you don't need to extend. Actually, you don't need to extend. Okay, we only need a P. And then this 9 segment, PA. Okay, this 9 segment intersect with this 9, the given 9, on the point A, so you have a PA. So that's step 1. You draw a 90-degree. You use the straight ruler to draw a 90-degree, and along this line, this leg, right? You have PA. So step 1, we are done. And then you choose a random. So let me erase this one. Okay. Then we choose a random point B on the given line. So you can choose a point B, says B here. Same thing, you use your straight ruler and construct. This time you don't know where is the end point, but you do know this line start. You can draw a ray start from B, the random point B, and you construct a 90-degree. And then you want to decide here the distance is D, you want to have the same distance D. How you do that? You use your ruler to measure. Or you can just open your compass with the same size and open here. Okay? And then mark this point. What? C. We mark it C. Let me change color. I mark it C. Then this 9 segment BC we have here. Okay, we have 9 segment BC. And then connect P and C. So let me use other color to connect the P and the C. I connect the P and the C. So let me move the whole graph here, okay? So I have P, this one, PA. So I have PA here. And I have BC here. And connect these two lines. Connect P and C. Connect P and C here. So then I have this PC, 9 PC. 9 PC is parallel, guarantee parallel. Why? Because same distance. Distance means 90-degree. You guarantee that. So we follow the definition of parallel lines to construct a line parallel to given line L. Then we are done. Okay. So let me make this page here for a little while, so you can screenshot this page. And then we are keep going to next page. Okay. So let me make it bigger. And then we go to next page. So remember perpendicular, 90-degree, then you can find the distance. So perpendicular is so important. Then let me make it smaller again, sorry. Okay, here. Okay. Now there's one thing I want to mention is, let me choose this color, blue color. PA perpendicular to line arrow and PC. Where is PA? PA perpendicular to line arrow and the PC. So when you have a distance perpendicular to the given line, also will be perpendicular to the parallel line. So when you have two parallel lines, this line segment will be perpendicular to both. So same thing, this is 90-degree, this 90-degree. Both are 90-degree. That's very important when we talk about perpendicular. So same thing, if you have a parallel line and you draw a perpendicular line, then guarantee they are all 90-degree. They are all 90-degree. Okay, and why is that? If we have more time, or probably next video after we learn more, I will spend more time to prove the detail or talk about the detail, but it's kind of easy to understand, okay, because that's follow the definition of the parallel line. And also you can say that since these two lines parallel, so any point to this line need to be 90 degrees by the definition, and any point from this line to the given line also need to be 90 degrees. So same thing. Why this is 90 degrees everywhere here? Because followed by the definition, but we still can use some proof to make you feel more comfortable to accept the 90 degree everywhere. Not everywhere, I mean, if one angle is 90, then this will be 90, this will be 90, this will be 90. After we learn the congruent triangle, then easier for you to understand. But right now, so that's the same idea. BC will perpendicular to both L and the PC. Since the reason kind of here, the distance, the shortest line segment between a point and a line is the line segment that is perpendicular to the given line. Okay, so this up to here, we are talking about the parallel lines. If you have a distance, same distance everywhere, means perpendicular, then we can construct the parallel lines. And keep going, we use this property, but still keep in mind perpendicular make a very important idea for you to understand the coming content. So how about if you have two lines, not necessary to be parallel, maybe parallel, maybe not parallel, okay? Doesn't matter parallel or not, but if you have a transversal, I would like to use T as a transversal. So two lines be cut by a transversal, then it will form two groups of angles. So those groups of angles, I give it a number 1, 2, 3, 4, 5, 6, 7, 8. Now they have a special name. Corresponding angles means the same position. So this is right. Let me use just R as a right. This right up. This depth up. This right and going down, right? Let me use right and up, depth up, right down, this depth down. Same thing, number 6 compared to these two lines. This right hand side of the transversal and the upper above the line. This is on the left hand side of the transversal and also above this line. Angle 8 is on the left hand side of the transversal and is below this line, below line 2. This on the right hand side and below the line 2. So you can see the R up, right? So let's talk about start from angle 1. You have depth up, depth up. So angle 1, angle 5, we call it, they are corresponding angles. Same thing, angle 2 and which angle should be together, angle 2 and angle 6. Okay, so keep going, you can finish it. and alternate interior angle. Let me erase all the mark here. When you talk about alternate interior angle, alternate interior angle means inside these two lines. Interior angle means inside. And the alternate is different side of the transversal. Different side. So it means angle 3 and the angle 5, they are on the different side. And the angle 4 and the angle 6. We call this alternate, different side, and the interior inside these two lines. Same side interior angle. Let's talk about alternate exterior angle first. So you have see this two is outside. We call it exterior. And this is the same side, right? And we are talking about the outside. Alternate exterior angle is outside. Exterior angle. Let me use other color. Okay. So angle 1, alternate means different side of the transversal. And the outside is not the interior. So it's outside, right? So angle 1 and the angle 7 is the alternate exterior angles. Angle 2, angle 8, angle 2, angle 8. Now same size interior angle. Let me erase all the marks. Same size interior angle. Let me use which color? Red color. Same side. Same side means same side to the transversal. Okay. Either this side or this side. Interior means inside. So you have angle 4 and the angle 5 is same side interior angle. Angle 3 and the angle 6, same side interior angle. Okay, so I introduced the definition of 1, 2, 3, 4. Then we are ready to talk about something more important. Now go back to Euclidean number 5 portrait number 1. First one. And this is kind of interesting. See, usually, for example, you have two numbers, x and y. X and y. These two numbers, if you have two numbers, x and y, these two numbers, maybe x greater than y. Maybe x equals to y. Maybe x is smaller than y. Only 3 choices, no other choice. And then we are going to use this concept here. Okay. And this is portrait. I said that this portrait is kind of hard to understand, but I try to use this to explain for you. Okay. So say if a straight line intersect two other straight lines, form interior angles on the same side. That on the same side. Same side interior angles, right? So same side interior angles. Let me go back. Same side interior angle. These two, same side interior angle. All these two, same side interior angle. We just talk about that. It said if same side interior angle plus together less than 180, then these two lines will eventually meet. Okay, so remember if we had two parallel lines, and if you try to draw perpendicular line, then it will be 90 degree. 90 plus 90 is 180. So if it's 180 degree and happen to be perpendicular, not necessarily need to be perpendicular, but I just use this example. Okay, if 90 degree, then they will be parallel. They never meet each other. How about if I don't have perpendicular line? I have this not a perpendicular line, and these two angle. How about if these two plus together equal to 90? So if let me make a bigger, draw it a bigger picture so you can see that. Okay, so if you have transversal happen to be perpendicular to both lines, then easy, you know it need to be equals to 180. How about if smaller than 180? If smaller than 180, what happens? Means angle smaller, right? If angle smaller, then this one should be bigger. Make sense? Okay. So if on the left hand side, angle smaller, so this angle plus this angle smaller than 180, then they will meet. So kind of obvious postulate if I explain this way. But why this one is hard? It only says if less than 180 degree, then they will meet. They didn't say parallel. They just say not parallel. Okay, so that's why this is hard. Remember I said that we need to learn more in order to understand better. We have not done logic yet. So far, because this is postulate, as long as you feel good, you understand, you accept this postulate, then we are fine. Okay. So again, if 90 plus 90 is 180, that's good. But if this two line or this transversal not the okay. So even though if you had two parallel lines, but if your transversal is not a perpendicular line, it's slanted. Let me change color. It's this way, not a 90. Then what happened to these two? Okay, again I said if if this transversal form a 90 degree, then we know it's parallel line. But if not 90 degree, can it still be parallel? Can it still be parallel? It's still possible. Okay, and it says if these two angle 4 and the angle 5, is these two angle plus together smaller than 180? This plus together smaller than 180, then eventually they will meet. So they won't be parallel. They won't be parallel. So they cannot be smaller than 180. But if it's not smaller than 180, if it's smaller than 180, the other side should be greater than 180, right? So the other side, you may have 3 and 6, and the 3 plus 6 should be greater than 180. Because when you talk about one side smaller than 180, means the other side need to be open wide, greater than 180. So number one basically is talking about, let me erase all the marks here so won't confuse you too much. Okay, erase. So basically, this postulate is talking about, in this case, angle 4 plus angle 5, right? Angle 4 plus angle 5. Angle 4 plus angle 5. If angle 4 plus angle 5, the major, less than 180. Or it's the same thing as when we talk about angle 3 plus angle 6. Angle 3 plus angle 6 is greater than 180. So no matter is less than or greater. The hardest part is this part only talk about less than. Okay, but actually same thing. One side less than, the other side will be greater than. So you consider they are talking about two things together. If means if not equal. Means if not equal. Not equal to 180 degree. So major angle 4 plus major angle 5, not 180. Major angle 3 plus major angle 6, not 180. Then they will meet each other, means not parallel. Okay. So if you, after you learn logic, it may be easier for you to say, okay, then if parallel need to be equal. But we have not learned the logic yet. So I won't explain by doing this way. So we don't talk about not. We talk about if smaller than or greater than won't make a parallel line. So it means greater or less than, not parallel. Now, what's the only possible choice? That is x equal to y. If x equal y, then will be parallel, right? So if not, if less than 180, then won't be parallel. If greater than 180, also won't be parallel. What's that choice? When angle 4 plus angle 5 equal to 180. So when two angles plus together equal to 180, it's talk about supplementary. Supplementary. So if same side interior angles supplementary, means plus together equals 180 degree, then L1 parallel to L2. Basically, this is what the portrait is talking about. Okay? And unfortunately, the the genius mathematician Euclidean, they didn't want to say this obvious to you. So many students feel it's hard. But if I said, if same side interior angles are supplementary to each other, then L1 and L2, 9192 will be parallel. Then you probably feel it's easier to understand. So this is the number one portrait. So number one portrait, I will formally kind of prove or explain on my theorem 1 proof. Okay? This one probably I need to name as theorem 2. Doesn't matter the name of the number of the theorem, doesn't matter. Okay. So let me go through this proof first. So just the same thing, because you have three possible choices. Either, so the same side interior angle either smaller than 180 or plus together greater than 180 or plus together equal to 180. Only three possible choices. Okay? And according to our portrait, the portrait is telling you this one won't be parallel, this one won't be parallel. Then what's the left over? The only one possible choice is equal. So we choose this one. The reason is because this portrait. Now, after this portrait, what else we can prove? Additionally, we can prove alternate interior angle will be equal. Alternate interior angle, yeah. Oh, I forgot to say interior. Alternate interior angle will be equal. So angle 3 and the angle 5 are alternate interior angle. Let me use pink color. Angle 3 and the angle 5. Now, because angle 3 plus angle 4 is a straight angle, so it's 180 degree, and then we just kind of prove it, or we agree with the portrait. Angle 5 plus angle 4 plus together is 180, so 180 is the bridge. So we can use chain rule. So we say angle 4 plus angle 5 equals to angle 3 plus angle 4. And then we take away angle 4 on both sides by algebra. Then we have angle 3 equals to angle 5. So that's our, you use algebra to calculate. Now, conclusion, we want to prove the only one possible choice is equals to 180, this one. And we just prove the alternate interior angle are equal. Now, how can you, so you can also prove the corresponding angles are equal. Corresponding angle means if two lines be cut by two line parallel and cut by a transversal, then angle 5 should be equals to you can say the angle 1 because the corresponding angle. Now you can go back to the corresponding angle definition. Now what's the proof? Easy, because angle 1 equals to angle 3, right? This proof I will leave to you, left to you to prove by yourself. Is kind of easy because if these two equal and these two equal because vertical angle, right? So angle 1 equals to angle 3 vertical angles. And the angle 3 equals to angle 5 because we just proved the alternate interior angles. Now angle 3 will be the bridge, therefore angle 1 equals to angle 5. So I kind of talk about the proof for you, and you can go home prove by yourself. Now I would like to talk about how about the distance in between. So when you said two line parallel, you have those angles. And if your angle equal, can you guarantee these two line parallel? I said this is logic. We are going to learn, we not learn yet, but we can prove it. Use the distance. Okay. After we learn more, we can prove it. So don't worry. I know probably you already use. You are way too smart, and you have many questions. Say, teacher, how about if this, if that? Fine. You are smart. I know that. Okay. But be patient. as long as you understand today's class, then that's good enough. Don't think about, oh, you learn one thing and then you need to automatically understand a lot more things. I didn't require my students this genius. If you you want yourself to become very, very genius, then it's beyond my ability to create a genius student, but you need to be genius by yourself. Otherwise, just be patient. Okay, so we keep going to another theorem. A triangle sum theorem. This one we talk about that on the first video, and then I will just talk about it one more time and without going through the proof. Okay, so because this straight angle together is 180, so A plus B plus C equals 180 degree. Now, when you talk about these two line parallel and cut by a transversal, this line, so you have this angle equal to this angle. So we say this angle A. This also angle A. So this angle A we can say is angle A. Okay? And this angle B basically is the vertex of angle B, triangle. And if you talk about these two lines parallel and cut by a transversal, this one, then you can see that these two angles are alternate interior angle. So angle C is here. Obvious, these three angles plus together, this A, this B, this C, it should be 180. So this we're done with the proof. And this is my written proof. You can have a screenshot if you want, but you can also find this one from our previous video. Okay, then we go to the very last one, proof. This proof follow this triangle sum theorem. So we already understand the triangle. Okay. Triangle inside plus together is 180. Three angle plus together equals 180 degree, no doubt. Now, this theorem is talking about the exterior, one exterior angle of this triangle. What's the exterior angle of the triangle means? If you have a triangle, then inside there's the interior angle. And what's the exterior angle? It's outside the triangle. Okay, so let me use which color? Outside the triangle. We call this exterior angle. Okay, and this exterior angle, let me mark it as angle 1. And from the picture, that's why draw picture is very important, really helpful. Angle 1 plus angle C is a straight angle, 180 degree. And the angle C plus the other two angles, because three interior angle plus together is also 180 degree. Now, if you use 180 as a bridge, then these two should be equal because they are the same thing, right? So angle 1 should be equals to, so this angle 1 exterior angle equals to the far away two interior angle plus together, far away. Angle 1, the exterior angle equals to far away two interior angle. sum of far away to interior angle. That's what's the explanation from this theorem. Okay, so kind of we are done. If you, I already write down the formal proof. So remember, if you have given triangle, they didn't tell you 180 degree. You have to automatically know when a given is 180 degree. Then by the definition or by the theorem, okay, by the definition, you have three angles, three sides. And by the follow the theorem, that's a hidden given. You can use it. So you say because triangle some theorem, then this interior three angles plus together equals 180. And then because the straight angle, you have another 180, and you can keep going. Okay, you also say this is a chain rule. Chain rule. And in the end, you write down conclusion. So we are done with today's video. And thanks for watching, and see you next time. Bye bye.